Okay, ji, Bismillahirrahmanirrahim. Let's start today over. This is which chapter number?
Sir, chapter number 2.
Chapter number 2. लेकिन हमारा ये लेक्चर कौन सा हो गया है?
सर ये 9th चल रहा है, 9th वीक है हमारा ये.
9th week. Actually, as chapter wise, I have given it at chapter number 2 because what was the chapter number 1?
Surface flow consideration.
Chapter number 1 was
design of unlined channels.
Is design of channels.
Yes,
Not
sir.
only unlined channels, we have also done line channels.
Yes, sir.
And you know, there is a problem in the book of Dr. Iqbal Ali. First problem is for the line channel. So we did the design of line channel and unlined channel in chapter number 1. Then chapter number 2 was basically low head diversion dams are barrages. Actually, chapter number 3 was the, surface flow considerations, to which I kept as 2, but said that this is 2B. And today we are discussing in reality over 4th chapter, but as this is the same as barrages, because this is all about barrages we are discussing, so I have kept the chapter number 2. But this is the part C of chapter number 2. Okay, just to give you the whole information about the barrages. So, but this is actually our 4th chapter. But as the detailed numbering, this comes under barrages. So in the previous lecture, or in the previous chapter, which was 2B, we discussed the surface flow considerations in the barrage design, and which parameters we were able to figure out or to point or to compute by after studying the last lecture which we studied. What you can do, by the way, what are the CLOs, course learning outcome, of the previous chapter? No answer.
Surface flow consideration के.
Surface flow considerations. After doing surface flow consideration, what you were able to do?
सर हम different components of barrage को describe कर सकते हैं.
Describe कर सकते हैं और design कर सकते हैं. For example, you are in a position to compute the length of the upstream concrete floor and also to find the level, to fix the level of upstream concrete floor. Am I right?
Yes, sir.
Yes, sir.
Okay. After studying the previous chapter, which was chapter 2B, so you are now in a position to fix the crest level of the weir of the barrage.
Yes.
Am I true? Correct? कर सकते हैं ना आप?
Yes, sir.
Okay. Moreover, now you are in a position to tell us what would be the locations on the downstream glacis where the hydraulic jump has to occur. बता सकते हैं?
Yes, sir.
Yes,
Which
sir.
approach you will use? By the way, which approach you will use to know the location of the hydraulic jump on downstream glacis?
So we have 3 approaches.
No. Only one is used to locate, to find the location of the hydraulic jump on the downstream glacis, that is Crump's curves or Crump's approach. Okay. The next, what you can do after studying the previous chapter, you are now in a position to fix the downstream concrete floor level. Is it true? How you will compute downstream concrete floor level? If you know the head loss and if you know the E2, which is the specific energy on the downstream side. So if you know the upstream energy level minus head loss, that is the downstream energy line, and minus E2 would be the downstream floor level. And then you are in a position to give the length of the downstream floor. Is it okay? How much you have to keep the length of the downstream floor, concrete floor? कितनी रखते हैं?
याद है शायद 4 to 5 times E2.
3.5 times the
downstream
क्या था?
energy.
Yes, minus
5 E2.
तो याद नहीं है ना आपको? So moreover, other than that, what you can design? How much should be the length of upstream flexible apron, and how much should be the length of downstream flexible apron? है ना? 1.5 and 2 times the scour depth. So anyway, that in the previous lecture, this all we have done. And today in the chapter 2C, we want to discuss the subsurface flow consideration in barrage design. As you know that barrages, under the barrages, we do not have very strong foundations because barrages are not usually provided in hilly areas where the river is flowing in hilly areas. These are provided over the alluvial beds. So under the barrage structure, there is sand, silt, shingle, etc. And if a barrage is provided over such type of the subsoils, then what happens? Water, in addition to surface flow, also flows under the barrage structure. All right. And under the barrage structure means subsurface flow. And we have to give the subsurface flow considerations. Okay. So when water flows under the porous medium or under this in the soil under the barrage structure, it causes two main problems. What are those two main problems? Number one is uplift pressure. It will apply uplift pressure to the structure. So due to that uplift pressure, this will tend to push the concrete floors in upward direction. And if the uplift pressure is more than the weight of the concrete floor, then of course these concrete floors can be lifted up and can be broken due to this uplift pressure. What is the second problem created by this subsurface flow under the barrage? There is undermining and piping. You know, when the water has to flow in the soil, then at the exit point from where the water will have to come out or water has to emerge, there, you know, the while water flowing, it applies seepage force on the sediment particles, on the soil particles. And you know, at the exit point, if you consider a soil particle, so the water is applying seepage force, which is in the upward direction. And how it can be resisted by the soil particles? By the submerged weight of the soil particle and also the friction offered by the surrounding soil particles. So it means the resisting force to undermining is basically the submerged weight and the friction, whereas the disturbing forces which the water wants to push the sediment particle, the soil particle, fine soil particle out, that is the seepage force. So due to that undermining, what happens? What do you mean by undermining? Undermining means the removal of the fine sediment particles due to the seepage force of water from the under the structure. So what happens if the continuously fine particles they are removed from a soil mass? What will happen? You know, the cavities will be generated, and then the whole soil mass can collapse, and you know the structure is resting over the this soil mass, so it has to collapse, and this collapse usually starts from downstream side. Now we want to discuss these both problems of the subsurface flow. Number one is the uplift pressure. The second is undermining or piping, separately in detail. Let us come to the uplift pressure. How we can define this uplift pressure? It is the residual pressure of the seeping water acting vertically up with the effect of trying to lift up the body of the barrage. For example, this is a dam structure. Suppose if this dam is provided on the porous medium, which is usually not the case, what is this diagram, by the way, which is in red?
Atmospheric pressure.
This is the pressure diagram, and the pressure is 0 at the water. Where is the water surface? And here, how much would be the pressure? Gamma times H, where H is this head of water or the depth of water, or rho GH, that is the same thing. Rho G means gamma. And how much would be the hydrostatic force which the water is acting on this dam face, that we have studied in detail in the subject of hydraulic engineering. What is the magnitude of the force? And also we have studied it in fluid mechanics 1. That is gamma AHC. Is it okay?
Yes, sir.
Okay. So the pressure at the bottom would be highest, and that is gamma times H. What about on the bottom of the dam? If the fluid is moving, if the liquid is moving under this structure, so the pressure at this point would be how much?
Same gamma H.
Would be same gamma times H. And now it reduces towards the outlet point. So here the pressure is 0. If the depth of flow here is 0. If there is certain depth of flow here on downstream side, the pressure would be equal to, let's say if the depth of flow is H1, then here the pressure would be gamma times H1. As the depth of flow is 0, so the pressure would be here 0. What is the distribution? Pressure distribution on bottom and on side, that is linear. So pressure is reducing in the direction of flow. By the way, why? Why the pressure is reducing? Yes? What is the reason? Due to head loss. So the head loss takes place in the direction of flow. Okay. Now, let's say this is a concrete floor of a hydraulic structure, maybe a barrage, and this is a barrier, and the depth of water is H dash. So how much would be the pressure at this point? That would be H dash into gamma. And how much would be the pressure head? That would be H dash. And if this is the depth of the, if the water is up to this level, and if T is the thickness, so how much would be the pressure at this lower point? That would be T. And this is the linear distribution. So how the pressure is reducing. So once it applies, so what about the pressure, uplift pressure, at which point it is the highest? Where, at what location of the hydraulic structure the uplift pressure is highest?
Entering point A.
Yes, on the upstream side. On the upstream side, the upward pressure of water is highest. Then it reduces as we move downstream. And what is the location where this uplift pressure is lowest? कहाँ होता है सबसे कम?
At the downstream of the concrete.
On the extreme downstream side of the structure. Okay. So if this much pressure is acting here, which is called as uplift pressure or residual pressure, residual. Why we call it as residual pressure? जो रह गया है बाकी, है ना? वो रह क्यों गया है? Because here these were the head losses. If I draw a horizontal line, so these were the head losses. So after subtracting the losses, whatever is the pressure, that is called as residual pressure. So it applies some residual pressure or uplift pressure at different points, and so that's why the gravity floors, these are gravity floors. The thickness of the floor or apron must be of greater weight than the force of the uplift pressure. So we have to see the force of uplift pressure. It should be lesser than the weight, the pressure which is generated by the weight. Okay. So determination of the uplift pressure is necessary. Now this is all about the uplift pressure, which acts on the any hydraulic structure if the water is moving under it. The next is undermining. As I mentioned undermining means removal of very fine soil particles due to the seepage force of water, and this continuous undermining process, and these very fine particles, they are removed, and once these are removed from at the outlet, at the point from where these these fine particles they are coming, they are emerging with water. At that location, the water would be muddy. The seeping water would be muddy. That shows that fine particles, they are also coming with them. And this is a second way by which it can endanger the stability of a barrage, because we allow the subsurface flow of water. So when the seepage velocity in microscopic flow channel in the subsoil under the apron is such that the seepage force at the exit point means from where it is taking out, becomes greater than the submerged weight and friction. There are two things. One is the submerged weight and friction of soil. These two are resisting forces, and when the seepage force, which is greater than that, so very fine particles becomes displayed, they start moving. Okay, and this continuous this can be observed as muddy water emerging from the soil surface. So for example, this is collapse. This is the failure of a dam due to undermining. This is a dam. This is not a barrage. So, so the water was seeping inside, which we normally do not allow in case of dams. We allow in case of barrages. Okay, but you see, due to some fault, due to some problem, inappropriate construction of the dam, the seepage started, and the seepage of the water resulted in the undermining. And initially, you know, maybe from one point, or maybe from this point, the piping was taking place, and then this hole, with gradually with time, it was increased, and now you know, this dam is emptied. Otherwise, it could have broken the maybe some part of the dam, and finally it could have resulted in the dam breakage. So this is the undermining. So with this continuing process of undermining or piping, the removal of fine particles causes unequal settlement of the subsoil and ultimately collapse of the structure due to piping. So these both phenomena, the uplift pressure and undermining, these are very serious, and we must design a hydraulic structure considering the forces exerted by these two phenomena, that is the uplift pressure and undermining. Now the seepage, now the question is, we must determine the uplift pressure we must find some ways or means by which we can determine the uplift pressures and also the undermining. So a number of methods are available, but these four are the very common methods. One is by using the flow nets, or graphical method by which we can compute the uplift pressure and also you know, the undermining phenomena. The second is Bligh's creep theory. The third is Lane weighted creep theory, and the fourth is Kosla's method. So these are the methods which help us in determining the uplift pressures on the barrages or any hydraulic structures, and also the safety against the undermining or piping. The first one is the flow nets. I think you know very well flow nets. What are flow nets? What is the general definition of flow net which you have studied in fluid mechanics 2? Yes, please. Flow net. Flow net is basically
equal hydrostatic pressure.
No, that is
level same होता है.
No. What is flow net basically? Net को define करना है ना?
Yes, sir. The flow net is
basically
actually
graphical representation.
Yes.
Representation of ground flow.
Actually, it is the graphical representation of flow of water through the porous medium. Okay, with the streamlines, intersection of streamlines and equipotential lines. Streamlines are also called as flow lines and also known as psi lines. Psi lines, streamlines, yeah, flow lines, same thing. What are the other lines? Equipotential lines are phi lines. Okay, so it is the network of flow lines and equipotential lines that is called as flow net. Now here you can see it's a dam, and suppose this is the porous medium over which this dam is built, and this is the head on the upstream side. Now what are these lines which are in blue color? You can see ये कौन सी line है? What are these lines?
Flow net, sir.
कौन सी line है?
Equipotential lines.
No, these are not equipotential lines. These are flow lines. These are psi lines. These are stream lines. ये stream lines है ना? अच्छा, और if I draw a line exactly perpendicular to stream lines, what this line is called? इसको क्या कहूँगा? These are equipotential lines. Here the pressure is same at this point, along this line. Okay. ऐसे ही है ना?
Yes, sir.
Yes, sir.
So this is the flow net, and the water always flows from which side to which side? From higher pressure head to lower pressure head.
Low pressure.
Yes, why the water is flowing in this direction? So the same is mentioned here. So hydraulic structure on permeable foundation. So this is a permeable foundation. Water flows from a region of high level to low level. Okay. So that is the flow net. Now we want to consider, the concrete floors. So this is a concrete floor, like maybe the concrete floor of a barrage. And what here we have provided? What is this structure? ये structure कौन सी है?
Sheet pile.
This is the sheet pile. So where we have provided the sheet pile? On upstream side or on downstream side?
Upstream side.
Sir, upstream.
How you going to know that?
both पे भी होता है.
This is the H. This is the head. है ना? This one is the head, capital H. So this is the upstream side, this is the downstream side, and these are the stream lines. These one are the stream lines. And these lines are equipotential lines. So here how much was the pressure? 100% of H. As you go down, here how much would be the pressure head? 90% of the H. As I will further go down, 40% of the H. And here, as there is no depth of water, so here how much is the pressure head? 0% of the H. It means the pressure here becomes 0. All right. Okay. Now we want to see that how much are the uplift pressures on the concrete floor. So this is the concrete floor. This one is the concrete floor. So now which line will give us the value of the pressure? Pressure or pressure head? It is the psi line or phi line? Phi line, sir. Equipotential line. Okay, how much is the pressure here? 30% of H. And what is this line gives us? How much is here? 25. 25% of H. And how much at this point? 15% of the H. And how much should be here? यहाँ पे कितना होना चाहिए? In between, maybe 28%. 28% of H. Okay, so how much is the pressure head varies on the concrete floor? On this side, high pressure, 28% of H, and on this side, low pressure, 15% of H. It means we can say that the pressure head, when a sheet pile is provided on the upstream side, the pressure head varies from 28% to 15% on the concrete floor. Is it okay?
Yes, sir.
Now,
Yes.
okay, now this is our concrete floor here, and one sheet pile is provided on upstream side, another on downstream side. Now these are the side lines, are the stream lines, and these are equipotential lines. Can I know that how much is the pressure here at this upstream point? It is about 55% of H. 55% of H. Okay. How much is the pressure at here? About 45% of H. So which is you can see from here. So how much pressure head varies when we provide two sheet piles here, maybe the 55% on the upstream side and 45% on the downstream side, which is the uplift pressure. Okay.
Sir?
Now come to yes.
Sir, if you look at this diagram, sir, अगर sheet piles हम बढ़ा रहे तो सर उससे तो हम pressure को बढ़ा रहे, मतलब sheet
Yes.
piles का फायदा क्या हुआ?
Yes, that we will discuss later on.
Okay.
Sheet pile का बहुत है. Sheet pile is helpful in what? That we will discuss at a later stage. Okay.
Okay.
All right. Now this is the third structure, and this is our concrete floor. Oh, sorry. Only this is the concrete floor, and sheet pile is provided. Where the sheet pile is now provided? On downstream side.
Downstream side.
So how much is the uplift pressure on upstream side would be? This is how much? 80 and 70. What is in between? 85. Okay. How much is the uplift pressure here? 70%. So it means the uplift when we provide a sheet pile on the downstream side, the uplift pressure is roughly varies from 70 to 85%. Now, considering these three diagrams, what is the location of the sheet pile which gives us lowest uplift pressure?
Upstream.
Upstream पे. If a sheet pile is provided on upstream side, it reduces the uplift pressure, and the pressure becomes how much? 15 to 28%. What is the location of the sheet pile which gives us the highest pressure?
Downstream.
Yes, if we provide a sheet pile on the downstream side. So this is just what is the effect of sheet pile on the uplift pressure. But you know, the sheet pile, if we provide on the downstream side, it gives us the highest uplift pressures. But as far as undermining is concerned, the downstream sheet pile is most effective. Okay, so that we will discuss later, that how it is effective. Now come to the creep theories. What the creep theory says? What is this one? This is a concrete floor, maybe of the barrage of any structure, and this is the gate, and this is the head of water. So according to creep theory, water creeps under the structure adjacent to the floors. Now the water will enter from this point.
Excuse me,
and
sir.
will GG.
सर जो लॉबी में वेट कर रहे हैं सर उनको प्लीज लेट इन कर दें।
वेट भी कर रहे हैं। There is only one guy.
Lobby.
Okay. All right. Okay, this is the basically creep theory. What the creep theory says that the water which flows in the porous medium, actually they say that it creeps exactly under the structure in this way. And this is called as creep theory. Okay. Now see this lower diagram. What is additionally we have provided? What are these three things which we have provided? ये क्या है? These are sheet piles. This is the upstream sheet pile, intermediate sheet pile, and downstream sheet pile. Now, according to creep theory, this says that the water creeps adjacent to the sheet piles and also bottom the floor. Now, how the water will creep? Water will enter from this point and they will move downward, and then adjacent to the sheet pile, it will then move upward, and then it will move horizontally under the floor of the concrete. Then it will move downstream, downward, adjacent to the next sheet pile, and then will move upward, and then will move exactly under the door, and then it will move vertically downward along the downstream sheet pile, and then it will move vertically upward along the downstream sheet pile, and finally it will emerge on the surface. So this is the concept given by the creep theories. Now come to the first creep theory, that is the Bligh's creep theory. According to Bligh's theory, water creeps along the bottom contour of the structure. Structure के bottom contour पे move करेगा. The length of the path of water is called the creep length. So this length covered by the water under the structure or along the structure, that is called as creep length. And the loss of head is proportional to the length of the creep. So this is very important point given by the creep theory कि जो head loss है is proportional to the length of the creep. As the length of the creep increases, head loss will increase. And you know how much would be the head loss on the entire length of the creep? When you know we are here, head loss is 0. As we move forward in the forward direction, head loss will keep on increasing. And when we will reach here, the head loss would be maximum. Okay. If HL is the head loss between upstream and downstream, and L is the creep length, then what would be the hydraulic gradient? HL over L. HL is the head loss in the length L, and L is the length of the creep. Okay. And you know, Bligh's theory makes no discrimination between horizontal and vertical creeps. So like this is the vertical creep here along the piles, and here it is horizontal creep. So it makes no difference. Now we want to understand this concept of the creep theory by considering a section as shown in the figure. Like let's say this is a concrete floor from point A to point B, and this is a gate which is closed, and it causes the head, capital H is the head on the upstream side. And now according to creep theory, the water will enter at point A and will move vertically down, and then will move vertically up and will reach at point C, and then will move or creep horizontally under the concrete structure and will reach at point D, and then will move vertically downward and then again vertically upward along the intermediate sheet pile, and then reach at point E, and then it will move horizontally under the floor and will reach at point F and will move vertically downward and then move vertically upward along the downstream sheet pile, and at point B it will emerge. So this is the how the water is going to move. So if we have hydraulic grade line, then we can know about the head losses. And now you see how much is the head loss caused by this upstream sheet pile. So this is the head loss which is caused by this upstream sheet pile, because this is the hydraulic grade line. So it what the hydraulic grade line gives us, by the way? ये क्या देगी हमें?
pressure head दे रही होती है.
It gives us the pressure head from here to here. This is the pressure head. Then what is this one? The upper one. ये क्या है?
Velocity head.
This is the head loss. देखें ये level था original water का. This was the original level of water on upstream side. Now this is the head loss is caused by this upstream sheet pile that we will discuss later how it is computed. So it means hydraulic grade line gives us the pressure head at this point. Now what happens to the pressure head as we moved in the downstream direction? क्या हो रहा है? कम हो रहा है ना भी pressure head. तो कौन सी चीज बढ़ रही है? हाँ भाई, ये क्या है?
Head losses, sir.
Head loss. Yeah, they are increasing.
Head loss.
Okay. Yes. So this is the head loss caused by the sheet pile. कैसे? HL over L is the hydraulic gradient into this length. D1 is the length of the sheet pile. तो कितना total creep length हो गई of this sheet pile? Twice of D1. So HL over L into 2D1 would be this head loss. Okay, then there would be head loss due to when the water will move along horizontally. Then this is the head loss due to the movement of water vertically down and up along the intermediate sheet pile. इसकी length कितनी है? D2. So how much would be this head loss? HL over L into 2D2. Okay, and then further head loss हो रहा है. ये देखें ये head loss हो रहा है ना. ये head loss किस में हुआ है? That is when the water moves along the under the floor. And then finally this is the head loss due to this downstream sheet pile when the water moves from point F to point B. तो इसकी depth कितनी है? D3. So how much is the creep length covered? Is 2D3. So how much would be the head loss? HL over L into 2D3. Okay. So this where L1 is the distance between the upstream sheet pile and intermediate sheet pile, and L2 is the distance between intermediate sheet pile and downstream sheet pile, and the B is L1 plus L2 are the total length of the concrete floor. Now I think something is clear about the pressure heads and head losses. Yes.
सर ये जो टर्मिनोलॉजीज हैं हेड लॉस के अंदर उन्हें एक्सप्लेन कर दें, जिस तरह क्योंकि हम हेड लॉस कंप्यूट कर रहे हैं अपस्ट्रीम पर भी और डाउनस्ट्रीम पर भी, मगर हम जो हमारे पास इक्वेशन जो बनती है उसके अंदर इटसेल्फ हेड लॉस गिवन है, तो यहाँ पर हाइड्रोलिक ग्रेडियंट ही क्यों यूज़ कर रहे हैं?
No, because the hydraulic grade line is a line which gives you the pressure heads. Okay? तो ये लाइन कहाँ लगी होती है फील्ड में. What do you think? Hydraulic grade line is an imaginary line?
Sir, it's an imaginary line. I'm talking about hydraulic gradient.
Yeah, hydraulic gradient is the slope basically of the hydraulic grade line.
So
Okay.
why we are using here it is?
Why?
So why we are using hydraulic gradient? since in that equation we have the head loss.
Yeah, actually this HL over L is the total head loss in this whole. This
Okay,
is the
sir.
hydraulic gradient, HL over L. Okay. Now,
Okay,
how
sir.
much would be the fraction of this in this one?
Okay.
So that is HL over L of 2D1. The proportion we are just computing. Okay.
Okay, sir.
I think you are confused with this. HL over L. This is hydraulic gradient. This is the head
Yes, sir.
loss per unit total length.
Okay, sir.
If
Now I'm clear.
No, if I multiply with this some distance 2D1, then this distance will cancel with this distance. What will left? Only the head loss, the unit of meters. Okay.
Yes, sir.
Now I think you are clear.
Yes, sir.
Okay, but my point is, under the hydraulic structure, what happens to the uplift pressure with as the water moves downstream? That I want to explain you. क्या हो रहा है अभी uplift pressure को?
So it is decreasing as the.
This is decreasing. The hydraulic grade line is telling us. Or what is happening to the residual pressure? Uplift pressure या residual pressure एक ही बात है, ठीक है ना? तो वो भी यही रेजिडुअल प्रेशर तो यही है. रेजिडुअल क्या है? लॉस माइनस करके जो प्रेशर आ रहा है दैट इज रेजिडुअल प्रेशर. Okay, now my second question is, as the water moves downstream, what happens to the head losses?
Sir, they are increasing.
They increase. So only I want to make this concept that when water flows under in a porous medium under the hydraulic structure, then the uplift pressure gradually reduces towards the downstream side, and the head losses they increase towards the downstream side. Okay. Now the total length of the creep, as you know, the Bligh theory says that the head loss at any point is a function of the creep length. So what is the total creep length? तो यहाँ पे total creep length क्या होगी? This is the D1 plus D1 plus L1 plus D2 plus D2. ये दो दफा D2 कहें तो फिर क्या क्या कह सकते हैं हम? 2D2 है ना? Plus this L2 plus 2D3. So this is the total creep length. So ये यहाँ पे ये आपको clear है जी? Is this equation is clear? D1 plus D1 plus L1 plus D2 plus D2 plus L2 plus D3 plus D3. So this is the total creep. इसको मैं simplify करूँगा तो कैसे लिखूँगा? ये L1 plus L2 plus twice of D1 plus D2 plus D3. Okay. What is L1 plus L2? ये किसके बराबर है? This is equal to B, which is the total length of the floor. So B plus twice of D1 plus D2 plus D3. This is the total creep length, according to Bligh theory. Now, head loss per unit length or hydraulic gradient HL over L. HL तो आ गया head loss, तो इसकी total length ये हमने यहाँ नीचे डाल दी, ठीक है? So this is the hydraulic gradient value. अब ये जो HL over L into 2D1, this is the head loss. ये कहाँ करोगा? This is due to upstream sheet pile, है ना भाई? ये head loss अगर किधर होगा? HL over L into 2D2, that is due to intermediate sheet pile. ये वाला head loss ये दिया हुआ है. And this is the head loss which will be contributed by the downstream sheet pile. So HL over L into 2D3. Okay. And now what is the next? Now we want to come to the real barrage structure. So this is the upstream concrete floor because this is the water level and this is the gate of the barrage. So this is the upstream concrete floor. This one is the upstream. ये क्या है?
Upstream glaciers.
Glaciers. This is the crest. This is the downstream glaciers, and this is the downstream concrete floor. ये चीजें क्या हैं? Sheet piles. AB is a sheet pile, and this is an intermediate sheet pile. This is the downstream sheet pile. Now, how the water will creep according to creep theory, and how we can compute head loss at any point. what would be the head loss at any point? So the creep length up to that point divided by the total creep length into the total head. This is the total head. Okay, capital H. Let's say if this is capital H, if this one is the capital H, okay. So if I want to compute the head loss here, sorry, the uplift pressure here or here or here, I can easily compute by this equation. So this is the equation to compute head loss. Head loss to any point is the creep length to that point divided by the total creep length into the total head H, which is the H here. Okay. Now suppose I want to find the head loss at this point F. Okay. So how much would be the creep length up to point F? That would be AB plus BC plus CD plus DE plus EF. So this much would be the length which is given here. ये length दी हुई है भाई, है ना? अच्छा, उसके बाद क्या है? The total creep length. How I can compute the total creep length? That is the AB जो यहाँ नीचे दी हुई है, ये वाली AB plus BC plus CD plus length DE plus EF plus FG plus GH plus HI plus IJ plus JK. So this is the total creep length. So आगे इसको किससे मल्टीप्लाई करना है? With the H जो head है, which is this one head. So this would give us the total head loss up to that point F. If I know the head loss up to this point, how I can compute the uplift pressure or residual pressure? Total H minus the head loss up to point F. So this is the uplift pressure which will be acting at point F. So do you have any questions? Kya bhai?
Sir, how we compute uplift F?
Yeah, this is uplift at F. This is equal to total H minus head loss up to F, and head loss up to F you have computed like this. ये आपने वही तो compute किया है. Okay, this is the head loss up to F. Could you got it?
Yes, sir.
Creep length up to point F divided by total creep length into H. This is the head loss up to point F. Okay. All right, now we want to take maybe 10-minute rest. So what is the time now? Now exact 11. So we will inshallah come back at 11:10. Okay, are you back?
Yes, sir.
Yes, sir.
So this is how the Bligh's creep theory we can use to determine the residual pressure or the uplift pressure on the hydraulic structure. Okay. Now, what is the next problem of the subsurface flow? The next problem is undermining, and what the Bligh says for the safety against piping or undermining.
सर
Yes.
कोई मैं डिस्टर्ब कर रहा हूँ वरना आपने बहुत आगे चले जाना था सर इसमें जो हम ये ब्लाइस थ्योरी पढ़ रहे हैं क्रीप थ्योरी इसको हम सेम इसी फॉर्म में यूज़ करते हैं इसमें मॉडिफिकेशन करेंगे हम बाद में
No, Bligh's theory is basically nowadays is not being used. Neither the lane theory is being used, which we are studying. Nowadays, only the Khosla theory is being used. Khosla.
Yes.
Khosla theory is widely used but then the question is why we are studying these two theories.
Maybe basic concept same हो सकता.
No. The reason is we want to basically build our understanding and how the people they have carried out the research and for our brain exercise. So we need all these theories to understand. Okay.
Yes sir, even though लेकिन जो ये ब्लाइस थ्योरी में हम फ्लो पाथ यूज कर रहे हैं हेड लॉस कैलकुलेट करने के लिए
जी
प्रैक्टिकली ये पॉसिबल भी है ये फ्लो पाथ.
Yeah, that's true. It is not possible. But anyway, this concept was given by the Bligh. So he started thinking, okay? तो वो जो creation है ना for creativity, that is the Bloom's taxonomy number 6. वो creativity के लिए हमें ऐसी चीजें समझनी पड़ती. Then our brain will work towards the creativity. अगर हम इन चीज़ों को नहीं समझेंगे we will not go in depth तो हमारी brain exercise नहीं होगी. So this is basically for our brain exercise. Otherwise in field nowadays the Bligh's theory and the lane theory they are not used for the design of barrages. Okay?
Yes.
लेकिन ये हमें चाहिए क्योंकि हमने for our brain exercise. So now how this theory checks the safety against piping or undermining. So the Bligh says that he has given the value of the C. C is the Bligh's coefficient for soil for various type of the soils. So these are fine sand, coarse grained sand, sand mixed with boulder, gravel, and light sand and mud. So these are the values of the C. Which C is maximum? Which is the Bligh's coefficient for soil? 15 is the maximum, and this is the fine micaceous sand, mica वाली ना, उसके लिए 15 है C की value, and the lowest is for light sand and mud. Okay, but even this sand mixed with boulder and gravel की value इससे भी कम हो सकती है, 5 भी हो सकती है. So what he says that Bligh says that the hydraulic structure would be safe against piping or undermining if the H over L is less than 1 over C. 1 over C. So 1 over C, what is 1 over C? This is 1 over C. This is the safe hydraulic gradient. 1 over C is the safe hydraulic gradient provided by the Bligh, and H over L is the hydraulic gradient. Okay, so सी के बढ़ने से क्या होगा? किस सॉइल की सी सबसे कम है? ये सैंड मिक्स विद बोल्डर एंड ग्रेवल, इट्स सी इज हाईएस्ट, इस सी इज लोवेस्ट, सो 1/c वुड बी हाईएस्ट। ये ज्यादा होना चाहिए ना, क्यों भाई? So actual जो hydraulic gradient है, it should be less than 1/c, which is the safe hydraulic gradient. So we will see that what is the type of the soil under the barrage, and we will select the value of C. We will compute 1/c, and H/L should be less than 1/c. If this is satisfied, then according to Bligh, over barrage is safe against piping or undermining. क्यों भाई, समझ आ गई? So this is the criteria given by the Bligh for undermining. Now I have one question. Suppose the over C value is 12, because this was coarse grained sand. We computed 1/c, and we also computed capital H/L. What is capital H? The head available we have. And what is the L? L is the creep length, and this is the hydraulic gradient. And what happened that this H/L was greater than 1/c. What do you think? The barrage would be safe against piping?
No sir.
No. Then how we can make it safe? क्या करें अब कि ये safe हो जाए?
Sir, we can increase the creep length, or we can increase the head. Total
Actually this should be lower.
Yes sir.
Head we cannot increase. Let's say head is fixed because the pond level of the barrage is fixed.
Yes sir. We can increase the creep length.
So what we can increase? We can increase to reduce this. We can increase the creep length. अच्छा जी, now please tell me how we can increase the creep length. वो कैसे increase कर सकते हैं? ये now the figure of the barrage is just before you.
Sir, it can be increased by increasing the depth of the sheet piles.
Okay, one way is that we can increase the sheet pile lengths, but you know there are certain limitations. Another approach, we can give additional sheet pile. ये मैं sheet pile दे देता हूँ H point पे, then again I am increasing the total creep length. दूसरा मैं क्या करूँ? Can I increase this length of the concrete floor और ये sheet pile इधर ले जाऊँ?
Yes sir.
ये मैं upstream concrete floor बढ़ा दूँ और sheet pile यहाँ ले आऊँ. So I have many options. By any option, if I am increasing the length of the creep, doesn't matter that it is the length is increased by a sheet pile or by a concrete floor. ये creep theory तमीज़ ही नहीं कर सक रही इसमें, है ना? Because the weightage of this length, vertical length and horizontal length is taken equal. So, but anyway, if I am designing a barrage using creep theory and my barrage is failing in undermining or piping, then what I have to do? I have to increase the creep length. And how I can increase the creep length? Either by increasing the length of the concrete floor or by increasing the vertical lengths of the sheet pipes. Then my creep length will increase. And on what basis then I will decide that which option should I go? क्या मुझे concrete की length बढ़ानी है या मुझे sheet pile की length बढ़ानी है?
The cheaper one.
Oh, very good. Engineers always then make decisions on the basis of economics. Then I have to check which solution is cheaper. Then I have to go for that solution. So in this table, this is the table 3.1, which is given in the book of Dr. Iqbal Ali. And these are the Bligh's values for several type of the soils. 1, 2, 3, 4, 5 type of soil. यहाँ पर 4 दी हुई है ना, तो उसमें एक ज़्यादा है. So anyway, that we can, and here also the lane values, still the lane theory we have not yet discussed. Now pressure तो हमने निकाल लिया था, uplift pressure, but how we can check the safety against uplift pressure? क्यों भाई? अब हमने हाइड्रोलिक स्ट्रक्चर को ये देखना है कि हमारी हाइड्रोलिक स्ट्रक्चर should be safe against this uplift pressure. So what is the basic concept? The pressure generated by the weight of the concrete should be greater than the uplift pressure acting of water in upward direction. So that is the basic concept. And for that, what we can do? So we can just compare the pressures for equilibrium condition. So gamma W into H dash. What is H dash? H dash is the residual pressure or the uplift pressure at any point. Into gamma W would be the pressure. This is the uplift pressure at any point. And what is this one on right side? What is the gamma W into G? ये क्या है? This is the specific weight of concrete or material. If I know the G of the concrete material, or I directly put here of concrete, इसको मैं gamma of concrete कर सकता हूँ, है ना? Into the T, which is the thickness, because how much is pressure? Pressure is gamma times H. तो ये जो thickness concrete की होगी, so if you will equate them, finally you will get this solution. So how much should be the thickness of the concrete? So the thickness of the concrete should be more than or equal to gamma of water over gamma of concrete into the residual pressure head. या pressure simply uplift pressure head. Okay. So this is the very simple equation to cater for uplift pressures. Any question about this? ठीक हो गया?
Yes, sir.
Okay. Now I have one question. If my uplift pressure is 1 meter, 1 meter is the uplift pressure head. How much I need the thickness of the concrete? Gamma W over gamma of concrete. What is the gamma of water in English system? कितना है भाई?
Simply 1 over specific
62.4.
62.4 pound per cubic foot. And how much is the gamma of concrete? RCC का कितना होता है? 150. इसका रेशो क्या आया?
Less than 1.
यार वो तो पता है, less than 1. 62.4 divided by माशाल्लाह 0.416 या 0.42 लेने हैं roughly. So if the uplift pressure head is 1 meter, then the thickness of concrete floor required is 0.42 meter. Is it okay?
Yes, sir.
हाँ, तो ये 42% याद रखें, 42%. अगर pressure head जो है वो 2 मीटर है, तो how much would be the thickness of concrete floor required? 0.84 meter, है ना? And so on. Now a number of structures were built according to Bligh's theory. Some of them were successful and other failed. Some structure they were failed. Sakhar Barrage was constructed in 1932 by using Bligh's theory. And luckily, this structure is still standing. Okay. Now we want to solve few numericals by using Bligh's theory. This is our problem. Find the hydraulic gradient. What is hydraulic gradient? HL over L
creep length sir.
and uplift pressure at a point 15 meter from the upstream end. So this is a point and the 15 meter is here. It means we are interested to find this pressure at point C, uplift pressure, given in the figure. Okay, now we will solve this. So can you compute first HL over L? तो H over L कैसे निकालेंगे? H divided by L. H कितना है भाई? How much is H? कितने मीटर है? हैं? 6 मीटर है ना? And how is the total creep length? अब देखें टोटल क्रीप लेंथ जो है ना वो कितनी बनती है. वो दिस इज 6 मीटर प्लस 6 मीटर ऐड करते जाएं. This take your calculator. So 6 plus 6. Then what I have to add from here to here? एक शीट पाइल ये है. This is another sheet pile. This is another sheet pile. कितने टोटल शीट पाइल हैं? 3. अच्छा जी, ये हम यहाँ पहुंच गए. Now plus how much is distance, horizontal distance from here to here? वो कितना है?
10 meter.
10 meter. So 10 meter. Now go plus. अब नीचे आएंगे ऐसे. कितना नीचे आएंगे? 3 मीटर नीचे आए, 3 मीटर फिर ऊपर गए. Like this. Now we have to move from here to here. ये टोटल लेंथ कितनी है? 20 मीटर. So plus 20. Then ये आखिरी शीट पाइल की डेप्थ कितनी है? 8 मीटर. प्लस 8 और 8 16. तो 64. 6 divided by 64. So what would be the answer? 1/6 है ना? 6 हो गया ना? So this is the value of the hydraulic gradient. पहला जो पार्ट उसने पूछा है. या you can also tell in points. फ्रैक्शन में कितना आएगा? 6/64. 0.09 है ना? ठीक है. हाँ जी. सॉरी जी.
H over L 1/10 बनेगा almost 1/10.6.
नहीं H over L. अच्छा 1/, कितना? 1/6 नहीं होगा? हाँ?
No sir.
नहीं, ये 64 नहीं है. 6 कितना होता है? हाँ.
6 10 the 60, so 1/10.6.
ओके, जो भी 1/10.6 या वो आप उसमें लिख लें डायरेक्ट. कितना आया था? 0.09. 0.09 आया. ओके, दिस इज द हाइड्रोलिक ग्रेडियंट.
Yes sir.
ओके, नाउ वो कह रहा है 15 मीटर पर आप कंप्यूट करते हैं. 15 मीटर इज एट पॉइंट सी, है ना? यहाँ पे क्या निकालें? अपलिफ्ट प्रेशर निकालें. अपलिफ्ट प्रेशर. तो यहाँ पे अपलिफ्ट प्रेशर कैसे निकलेगा? सबसे पहले हम हेड लॉस निकालेंगे एट पॉइंट सी और कैपिटल H में से वो हेड लॉस माइनस कर देंगे, है ना? तो दैट वुड बी द अपलिफ्ट प्रेशर एट पॉइंट सी. यहाँ पे जो अपलिफ्ट लग रहा होगा प्रेशर. अच्छा जी. सो हाउ मच इज द क्रीप लेंथ अप टू पॉइंट सी? तो वो अब आप निकालें जी. और this divided by that into the head would be the head loss up to point C. ये head loss आया point C पे. तो point C पे देखें ये कितनी लेंथ है? ये 6 + 6 12 + 10 कितना हो गया? 22 + 6
28
और जमा ये 5. ये 5 ही बनता है ना? हैं?
Yes sir.
So this is 33. 33 हो गई जी क्रीप लेंथ अप टू पॉइंट सी, डिवाइडेड बाय टोटल क्रीप लेंथ कितनी है 64 इनटू द एज व्हिच इज दिस हेड। तो ये क्या आ जाएगा, ये हेड लॉस आ जाएगा। अभी ये हेड लॉस निकालो कितना हो गया 33 ओवर 64 इनटू द एज
3.19
3 डिवाइडेड बाय 64 इनटू 6 है ना, ये हो गया 3.1 ले लें। हाँ 3.09 है 093, तो आपकी मर्जी है 09 ले लें या इसके यूनिट क्या होंगे भाई
मीटर
है मीटर। अच्छा जी, अब हमने अपलिफ्ट निकालना है कि अपलिफ्ट प्रेशर कितना है, अपलिफ्ट प्रेशर हेड, ठीक है। तो वो कैसे निकलेगा, जो हेड है टोटल हेड माइनस हेड लॉस, सो दिस इज द हेड लॉस। तो ये आ गया 0.48 एच, तो एच 6, तो ये कितना हो गया 0.48 इंटू एच 0.48 इंटू 6 2.88। तो जनाब ये इसके यूनिट क्या होगा भाई 2.88 के
मीटर
मीटर। सो दिस इज द अपलिफ्ट प्रेशर हेड। अच्छा जी, अब कोई कहता है यार अपलिफ्ट प्रेशर निकालो कितना होगा, वो कैसे निकलेगा, गैमा टाइम्स एच। व्हाट इज द गैमा ऑफ वाटर इन सिस्टम इंटरनेशनल
9.81
9810 इंटू 2.88, कितना प्रेशर हो गया, यहाँ पर जो प्रेशर आया वो कितना आ गया भाई,
तो 28253
ओके 9810 इंटू 2.88, ये आ गया जी 28.25 है ना, 28.25। What would be the units?
kPa किलो पास्कल।
प्रेशर के यूनिट क्या आते हैं, न्यूटन पर स्क्वायर मीटर आने थे ना,
यस सर।
वो क्या होता है पास्कल, और हमने 1000 से डिवाइड कर दिया है तो ये हो गया किलो पास्कल, ऐसे ही भाई,
यस सर।
या किलो न्यूटन पर स्क्वायर मीटर। सो दिस इज द प्रेशर व्हिच इज एट पॉइंट सी, दिस इज अकॉर्डिंग टू ब्लाइज थ्योरी। आगे चलें। Now we have to solve one more numerical, and this is a concrete floor which is acting as a hydraulic structure. This is the gate, और ये head कितना है भाई इधर 5 मीटर is the capital H, वो 5 मीटर है मेरे पास। And now it is said that वो कहता है wear on a sandy soil is shown in figure below, find out the uplift pressures at 0.5 मीटर पे, 7 मीटर पे, 11 मीटर पे from the upstream end of a impervious floor. तो ओके आई विल फाइंड ओनली एनी वन, कौन सा कर लूँ, बी पे कर लूँ हैं, अच्छा बी
Yes,
पॉइंट
sir.
पे। हाउ आई हैव टू सॉल्व, फर्स्ट ऑफ ऑल आई हैव टू फाइंड द क्रीप लेंथ अप टू पॉइंट बी। कितनी क्रीप लेंथ है अप टू पॉइंट बी,
7 मीटर
7 मीटर नजर आ रहा है ना, 7 मीटर नहीं है क्रीप लेंथ यार,
17
17 है सर।
देखो मेरी बात सुनो, एक ये क्या है,
10
ये शीट पाइल एक है, ये डाउन स्ट्रीम शीट पाइल है, ये ख्याल रखना है, ये 2 शीट पाइल हैं। अब मुझे बताओ 5 और 5 10 और जमा 7 17 क्रीप लेंथ है, 17 मीटर। व्हाट इज द टोटल क्रीप लेंथ,
30 सॉरी
10 प्लस 20 कितना हो गया
44 सर।
30 और 14 44। सो ये हो गया जी, कितना निकाला था हमने पहले यहाँ तक 17 17. Total creep length is 44 into the H, which is 5 meter. Oh my God, ये खराब हो गया. So what is the answer? This is the, ये क्या है भाई? हेड लॉस है. हेड लॉस किस पॉइंट पे? बी पॉइंट पे. ये बी पॉइंट पे कितना आया भाई? 17/44 इंटू 5.
1.93.
17 divided by 44 into 5.
1.93.
1.93. तो ये 1.9 and 3 यूनिट क्या होंगे? मीटर्स. Now how much is the uplift pressure head at this point? वो कितना है? तो uplift pressure head कैसे निकालते हैं?
माइनस करते हैं.
H minus this. So uplift pressure जो होगा, uplift या simply हम uplift भी कह सकते हैं इसको, है? Uplift that is equal to this 5 meter, which is the H minus 1.93. What is the answer?
3.07 meters.
3.07 meter. And how much would be the residual pressure head? वो कितना होगा?
यही है सर.
वो यही होगा 3.07 meter. अच्छा, if somebody says के प्रेशर निकालें तो गैमा से मल्टीप्लाई कर दें, है ना? अगर फीट में है तो गैमा 62.4 है. If it is in system international, the gamma of water is 9810. So we have solved these two numericals as well. Any question up to this? कोई मुश्किल तो नहीं है? To compute the uplift pressures or residual pressures on a hydraulic structure using Bligh's theory, Bligh's creep theory. Okay. Now this is the next problem.
Excuse me, sir.
Yes.
ब्लाइस की थ्योरी में हम लेयर्स ऑफ सॉइल को भी कंसीडर नहीं कर रहे कि अगर 10 मीटर तक आप जा रहे हो तो 10 मीटर में काफ़ी तरह की लेयर्स ऑफ सॉइल आ सकती हैं.
No, that is not being considered. Only the creep length is considered. Only the creep length. Or creep length भी horizontal creep length or vertical creep length, they are equal. Okay. अच्छा जी, in this problem, अब ये प्रॉब्लम बैराज का ओरिजिनल आ गया है ना. So this one is this is the upstream concrete floor, this is the upstream glasses, this is the crest, this is downstream glasses, and this is the downstream concrete floor. इसमें कितने शीट पाइल दिए हुए हैं? 3. This is the intermediate. This is, you can say now it is the upstream, this is the intermediate, this is the downstream sheet pile. So suppose अगर इसमें ये कहते हैं कि जी पॉइंट E पे निकालें uplift pressure, तो कैसे निकालना है? First of all, we have to find the head loss up to point E. Head loss कैसे निकलेगा? The creep length up to point E divided by the total creep length, which is this one, into the H. H दिया हुआ है?
Yes, sir.
H दिया हुआ है या नहीं दिया हुआ?
Indirect दिया हुआ है आपको.
Yes, दिया हुआ है. ये इसका लेवल 200 है, इसका 197 है. So this minus then this 3 meter. 3 मीटर दिया हुआ है ना? तो इसका क्या मतलब हो गया? मैं हेड लॉस निकाल सकता हूँ at point E. Once I know the head loss, so how I can compute the uplift pressure? So uplift that is equal to this head. This is the 3 meter minus head loss up to point E. So that would be the uplift pressure or uplift at point E. ठीक हो गया भाई, तो मुश्किल तो नहीं है?
नो
ओके, ये लेंथ दी हुई है आपको?
यस सर,
ये दी हुई है?
-12
कहाँ दी हुई है? नहीं यार, माइनस वो तो ये लेंथ है, दैट इज द लेंथ ऑफ अपस्ट्रीम कंक्रीट फ्लोर। अच्छा, इसकी लेंथ दी हुई है? ये जो अपस्ट्रीम शीट पाइल है, इसकी लेंथ दी हुई है?
यस सर,
Yes.
दी
तो वो रिड्यूस लेवल माइनस करके आ जाएगी।
जी
6
जी,
मीटर आ जाएगी।
197 माइनस 191, 6 मीटर इसकी लेंथ है ना? तो लेंथ दी हुई है। अच्छा, तो इसकी स्लोपिंग लेंथ कैसे निकालेंगे?
हाइपोटेन्यूज है बेसिकली।
ये वाला दिया हुआ है डिस्टेंस, ये हॉरिजॉन्टल डिस्टेंस दिया हुआ है?
ये आ जाएगा।
नहीं दिया हुआ।
वर्टिकल दिया हुआ ना,
इसका सर
वर्टिकल दिया हुआ 1 मीटर है वर्टिकल।
वर्टिकल इज अवेलेबल।
माइनस
ये 198 माइनस 197, 1 मीटर ये दिया हुआ है, और ये स्लोप दिया हुआ है। जब ये स्लोप दिया हुआ हो और ये दिया हुआ, तो कैन आई फाइंड दिस एंगल और दिस लेंथ? स्लोपिंग लेंथ मैंने निकालनी है, मैं निकाल लूंगा, क्यों भी निकल जाएगा ना। अब मुझे बताइए हॉरिजॉन्टल डिस्टेंस कितना होगा?
4 मीटर।
वर्टिकल डिस्टेंस इज 1 मीटर,
हॉरिजॉन्टल 4।
हॉरिजॉन्टल 4 मीटर हो गया यार। अच्छा, अब अगर ये दोनों डिस्टेंस मुझे पता है, तो ये डिस्टेंस कैसे आएगा? अलोंग द स्लोप 1 स्क्वायर प्लस 4 स्क्वायर अंडर रूट, है ना?
यस
सो इट मींस आई हैव फर्स्ट टू कंप्यूट द लेंथ्स, क्योंकि क्रीप लेंथ में क्रीप थ्योरी में आई नीड द क्रीप लेंथ्स। तो हो जाएगा ना सॉल्व ये न्यूमेरिकल?
यस सर।
Okay, so this was all about the Bligh's creep theory. Now come to the next theory. What is the name of this theory? Lane's creep theory. ये उसके बाद में डेवलप हुई है। अच्छा, लेन ने शुरू में कहा in the beginning, he said that इसको weighted creep theory कहते हैं। उसने कहा it should be जो बेसिकली हॉरिजॉन्टल पार्ट की कंट्रीब्यूशन है वो इतनी ज़्यादा नहीं है एज कंपेयर टू वर्टिकल कंपोनेंट्स की कंट्रीब्यूशन है। तो क्रीप लेंथ उसने कहा टोटल वेटेड क्रीप लेंथ होनी चाहिए। इनिशियली ही सेड दैट द कंट्रीब्यूशन बाय द हॉरिजॉन्टल कंपोनेंट्स इट शुड बी हाफ एंड प्लस वी। इसकी मतलब है कंट्रीब्यूशन बाय वर्टिकल कंपोनेंट्स इन कंप्यूटिंग द क्रीप लेंथ इज मोर एज कंपेयर टू हॉरिजॉन्टल। और इसमें एच जो है वो ऑल हॉरिजॉन्टल कंपोनेंट्स आर ऑल स्लोपिंग कंपोनेंट्स हुज एंगल इज लेस देन 45 डिग्री। स्लोपिंग कंपोनेंट्स भी फिर एच में लेंगे अगर 45 डिग्री से कम है। व्हाट इज वी? ऑल वर्टिकल कंपोनेंट्स या स्लोपिंग कंपोनेंट्स जिनका एंगल 45 डिग्री से ज्यादा है, दैट वी विल टेक इन वी। इज इट क्लियर? लेकिन उसके बाद फिर उसने मॉडिफाई की लेन वेटेड क्रीप थ्योरी। सो दिस वाज द ओरिजिनल क्रीप थ्योरी, हाफ एच प्लस वी इज द कैपिटल एल। बाद में उसने कहा नहीं, कैपिटल एल इज एच ओवर 3 प्लस वी। सो द कंट्रीब्यूशन बाय द हॉरिजॉन्टल कंपोनेंट्स अकॉर्डिंग टू हिम इज 1/3 एज ऑफ द वर्टिकल कंपोनेंट। तो ये ब्लाइस से क्रीप लेन ने लेन has difference with the Bligh's concept. तो आपका क्या ख्याल है, ये ठीक था? उसका लेन का कॉन्सेप्ट ठीक था?
सर ये दोनों ही गलत थे।
नहीं, गलत तो थे, बट who was relatively you can say more logical among both?
सर आई थिंक लेन
लेन
इज मोर
लेन ने
लॉजिकल।
आगे हॉरिजॉन्टल कंपोनेंट है वो जनाब, वो भी इक्वली वैसे ही क्रीप लेंथ में कंट्रीब्यूट कर रहे हैं एज दी वर्टिकल कंपोनेंट। दिस इज रॉन्ग। तो व्हाट वर द बेसिस? अब उसके बेसिस तो देखें, वो क्यों कहा इसने, लेन ने क्यों कहा कि यार ये जो वर्टिकल हॉरिजॉन्टल कंपोनेंट हैं दे आर नॉट इक्वली ट्रीटिंग क्रीप लेंथ एज द वर्टिकल कंपोनेंट। अच्छा, उसने फिर क्या किया, ही हैज कैरिड आउट स्टैटिस्टिकल स्टडी ऑफ अबाउट 270 स्ट्रक्चर की स्टडी की उसने, जो पोरस फाउंडेशंस पे थी। एंड जो उसने ये थ्योरी लगाई, उसने फिर चेक की अपनी ये थ्योरी, तो हिज थ्योरी रिजल्ट मैच्ड वेल विद द ऑब्जर्व डेटा, वो काफ़ी मिलती जुलती उसको नज़र आई। अच्छा, उसने फिर जो जस्टिफिकेशंस दी हैं, अकॉर्डिंग टू दिस थ्योरी इन कंप्यूटिंग क्रीप लेंथ ग्रेटर वेटेज वाज गिवन टू द वर्टिकल पाइल्स या कट ऑफ्स देन टू हॉरिजॉन्टल फ्लोर। उसके रीजंस उसने ये 3 दिए हैं। पहला रीजन क्या है, उसने कहा जो सॉइल बीनीथ द स्ट्रक्चर होती है, इट मे सेटल एंड लीव एम्प्टी स्पेसेस विच विल बी एवरेज बाय पाइपिंग। तो वो कह रहा है कि वो जो सॉइल है वही सेटल हो जाती है कंक्रीट फ्लोर से नीचे, तो वो इसलिए वो इट इज नॉट इन कांटेक्ट। द सेकंड, इन प्रैक्टिस द कांटेक्ट बिटवीन वर्टिकल एंड steeply sloping surface is likely to be closer than along horizontal surfaces. अगर कोई vertical component होगा, ठीक है, तो soil का contact with that component is more stronger as compared to horizontal. ये यहाँ settle हो गई तो contact नहीं रहा. So vertical cutoffs are more effective against horizontal stratification to check the free flow. उसने ये कॉन्सेप्ट दिया कि ये जो फ्री फ्लो को चेक करने के लिए, रोकने के लिए, चेक मींस टू स्टॉप, वर्टिकल जो बेसिकली स्ट्रक्चर्स हैं, दे प्ले मोर इम्पोर्टेंट रोल, एंड ऑन दैट बेसिस he therefore suggested a weightage factor of 1/3 for horizontal creep as against 1 for the vertical creeps. Okay, so this was the justification given by Lane. So अब अगर वही जो पहली वाली डायग्राम हम देखें, तो if I want to compute the total creep length according to the Lane, so LL, this small l, capital L is for the creep length, the subscript L stands for the lane. Okay, तो वो ये हमने D1 प्लस, तो अब ये L जो है ना 1/3 हो जाएगा, और ये L2 भी 1/3 हो जाएगा. सो फाइनली द टोटल क्रीप लेंथ, वो जो ये फिगर थी हमारी शुरू वाली, दिस वन, इसमें हमने कंप्यूट की थी ना, तो ये इक्वेशन बनाई थी. अकॉर्डिंग टू ब्लाइज थ्योरी द टोटल क्रीप लेंथ है b plus twice of this, but now it is changed. Now it is 1/3 of b plus twice of the same, the vertical जो depth थी of the cutoffs. Is it easily understandable? क्यों भाई?
Yes sir.
Okay, तो ओनली जो हॉरिजॉन्टल पार्ट है उसको 1/3 कर देना है इन कंप्यूटिंग द क्रीप लेंथ, बाकी सारा कुछ वही है. अच्छा, अब ये है कि जो लेन ने क्या कहा है, टू इंश्योर सेफ्टी अगेंस्ट पाइपिंग, कि अगर मैं कोई बराज डिज़ाइन कर रहा हूँ विद लेंस थ्योरी, तो हाउ आई कैन चेक द सेफ्टी अगेंस्ट पाइपिंग और अंडरमाइनिंग. तो इसने भी तरीका वही रखा है. इसने कहा है जो हाइड्रोलिक ग्रेडियंट है H/LL, it should be less than 1/CL. So this L stands for lane. तो ये C की वैल्यूज हैं जो given by the lane for various materials. 8.5 से 1.6 is the lowest. Clay soils के लिए उसने बहुत थोड़ी दी हैं. And this is the lane's safe hydraulic gradient, which is this one. So H/LL should be less than 1/CL, and this is the basically Lane's approach to compute the safety against piping or undermining. So if you have any questions, you are welcome. Kyonji? तो uplift pressure जो आएगा by Bligh's theory and by Lane's theory, would it be same value or it would be different?
सर डिफरेंट होगी क्योंकि क्रीप लेंथ ही हम लोग हॉरिजॉन्टल कंपोनेंट्स का 1/3 ले रहे हैं.
अच्छा, चले अब मुझे बताएं, टोटल क्रीप लेंथ जो लेन दे रहा है वो कम दे रहा है, कौन ब्लाइस और लेन में टोटल क्रीप लेंथ किसकी ज्यादा है?
ब्लाइस की सर।
ब्लाइस की ज्यादा है, लेन कम टोटल क्रीप लेंथ कहता है एक स्ट्रक्चर की होगी। तो किसी भी पॉइंट पे जो हेड लॉस होगा वो क्रीप लेंथ ब्लाइस थ्योरी ज्यादा दे रहा है या लेन थ्योरी ज्यादा दे रहा है हेड लॉस?
सर वो ब्लाइस ज्यादा दे रहा है।
देखो डिनोमिनेटर कम हो गया ना।
यस सर।
जब डिनोमिनेटर लेन में कम हुआ है तो फिर क्या होगा?
लेन में हेड लॉस बढ़ जाएगा।
लेन में बढ़ जाएगा। तो अपलिफ्ट प्रेशर किसी पॉइंट पे फिर कौन सी थ्योरी ज्यादा देगी, लेन या ब्लाइस?
ब्लाइस ज्यादा देगी।
ब्लाइस।
है जी,
ब्लाइस
ब्लाइस तो नीचे वो तो ज्यादा ले रही है, नीचे कैपिटल एल की वैल्यू उसकी बड़ी है,
लेकिन उसका
ये
हेड
कम।
लॉस तो कम हो गया ना ब्लाइस का।
So anyway we have to check, है ना?
यस सर।
We have to check, then we can say that कि किससे वैल्यू ज्यादा आ रही है। Anyway, this is all about the Bligh's theory and Lane's theory, and we want to stop here. Next time we would like to start the Khosla theory, which is the nowadays widely used theory for the design of the barrages. तो एक चीज यहाँ पे ये सोच लें कि Bligh's और Lane theories, these have become obsolete and are not being used for the design of barrages. Okay? तो पढ़ हम क्यों रहे हैं? फॉर आवर ब्रेन एक्सरसाइज, ताकि हमें सोचना है, वी शुड बी एबल टू थिंक। ऑलराइट, तो इफ यू हैव एनी क्वेश्चंस यू आर वेलकम। क्यों जी? Do you have any questions?
No sir, it's clear.
Okay, shall we stop now?
यस सर।
Yes sir, ये काफी अच्छा है।
हाँ जी।